Okay, now we're going to get into solving systems that are called 3 by 3. And this is where you have 3 equations and 3 unknowns. And we're going to be dealing now with equations that has x's, y's, and z's in them. And when we find the solution of a system of 3 by 3s, instead of having an ordered pair now, where we would have x, y, we're now going to have what's called an ordered triple, where we're going to have a point that's x, y, and z, because we have 3 variables. So now we're solving equations that look like this. We have ax plus by plus cz is equal to d. A, b, c, and d are just numbers. And your x, y, and z are variables. And this is why we're now working in 3 dimensions, because we have 3 variables. So now, instead of having y and x, we're going to have a 3rd dimension, z, that pops out of the page. And when we look at this equation, before we were looking at ax plus by is equal to c, where we had x and y with coefficients and it's equal to c, some constant. This is a linear function. It's in a different form than y equals mx plus b, or point slope form, but this is just a line. Now when we have 3 dimensions with an x, y, and z, this equation here represents what's called a plane. Imagine a plane looks like a piece of paper that goes on in every direction for infinity. Okay, now when we solve a system of 3 by 3, there are different situations you can run into, just like when we solve for a 2 by 2 system. We could have no solution, we could have infinite solutions, or we could have 1 solution. There are different situations that you could have with a 3 by 3 system. And in this first bunch of pictures here, I'll call this picture 1, picture 2, and picture 3. These are all pictures of a situation where you would have the special case of no solution. And that is because in order to get a solution for a 3 by 3 system, all the planes have to intersect at least 1 point. So if I look at, we'll call this plane 1, we'll call this plane 2, and we'll call this plane 3. If you look at the planes 1, 2, and 3, 1 and 2 intersect. 1 and 2 intersect right here along this line. 1 and 3 intersect along this line. But if you notice, 2 and 3 don't intersect. And in order to have a solution, they all have to intersect at least 1 point. So that's why this case is no solution. If we look at the next picture, if I call this plane 1, if I call this plane 2, and if I call this plane 3, if you notice 1 and 2 intersect, 2 and 3 intersect, and 3 and 1 intersect, but they don't all intersect together at 1 point. And then in the last situation, none of them intersect. They're all parallel. So that's pretty obvious. None of them intersect at all. So that's the case of no solution. So any of these top cases are pictures of what it would look like for no solution. Now, in the second picture, this is the case where you would have 1 solution. The solution would be where all 3 planes intersect, and all 3 planes intersect right there. So that point where they would all intersect is the point x, y, z. And this last example here, this is the case where you have infinite solutions. This is one of our special cases. Because if you look, all three planes intersect, but they all intersect at a line. That's this line right here. Remember, these planes go on forever. Any XYZ point that lies on that line is going to be a solution. And that's why this is infinite solutions, because there's an infinite number of points on that line. In order to solve a system of 3 by 3, this is what you want to do. The first step is to pick any two equations and pick one variable to eliminate. Then in step 2, you're going to pick two different equations and then eliminate the same variable. That is the key step, is when you pick a second set of equations, you have to pick the same variable to eliminate. If you don't, that's when it's going to get really messy and it's going to get really frustrating. I can't stress that enough. When you pick your second pair of equations, you want to eliminate the same variable you did in the first two equations. And then what's going to happen, let me scroll down, I'm running out of room here. Step 3, what's going to happen is in step 1 and step 2, you're going to create a 2 by 2 system of equations. Then you're going to have a 2 by 2 system of equations to solve. And then once you do that, you're going to go back. You're going to back substitute to find the last two variables. And then, of course, you can check your answer. If you want to check your answer on the app, on the calculator, you can. Or you can check it by hand. If you check it by hand, then you have to put that X, Y, and Z value into each equation and make sure it works for all three equations. Okay, so looking at the first example, I'm going to call this equation 1, equation 2, and equation 3. I can't stress this enough. You want to make sure that you stay organized and neat and write down your steps as you go along, because if you make a mistake, it tends to get very messy for you to have to try to backtrack to find your mistake if you're not organized. So it's really important that you label everything and write down your steps as you go along. It really helps you save time if you're trying to backtrack to find a mistake. Okay, so I labeled my equations 1, 2, and 3. So the first step, if you look at the steps that I wrote down, the first step is to pick any two equations and then pick one variable to eliminate. So I'm going to pick equation 1 and 2. And if you notice, equation 1 and 2 is already set up where I can eliminate the y because I have a plus 1y and a negative 1y. So I'm going to write down equation 1, x plus y plus z is equal to negative 7. And equation 2 is x minus y plus 2z is equal to negative 9. And now I'm going to add vertically and eliminate that y. I'm going to call this new equation that I'm coming up with equation 4. So I get a 2x, the y's disappear, and then I'm left with 3z is equal to negative 16. So I'm calling that equation 4. Then I'll use a different set of equations. So let's say I use equation 1 and 3. But here's where students go wrong. You have to make sure whatever variable you eliminated in the first two equations, you eliminate that same variable in the second two. So when I pick equation 1 and equation 3, I got to eliminate y again. Okay, now equation 1 and equation 3, I picked those because y also eliminates very easily without me having to do anything. So I'm going to add vertically, and I'm going to get 2x, the y's disappear, and I'm left with 4z is equal to negative 18. I'm going to call that equation 5. So now if you notice, I got two new equations, 4 and 5. It's a system of 2 by 2 now. I got two equations, 4 and 5, that have x's and z's in them, and now I can solve those two just like we did previously with substitution or elimination. So what I'm going to do is I'm going to take, let's say I take equation 4, and I'm going to multiply it by a negative 1. And that way I have a 2x in one equation and a negative 2x in the other equation, and then I can eliminate x, and I'm left with z. So I'm going to take equation 4, and I'm going to multiply by negative 1. So that gives me a negative 2x minus 3z is equal to positive 16, because I multiply everything in that equation, equation 4, by negative 1. Now I add vertically, and I get rid of my x's. So I'm left with 4z and a minus 3z give me z is equal to, and then I have negative 2. Now that I have one of my variables, I start working backwards to plug in to find my other two variables. I don't want to plug the z is equal to negative 2 into one of the original equations, because if I do that, then I'm still left with two unknowns. What I want to do is backtrack. I want to plug it back into either 4 or 5, because then I can solve for x. So I'm going to take negative 2. Let's say I plug it into equation 5. So I'm going to take 2x plus 4 times negative 2 is equal to negative 18. That gives me 2x minus 8 is equal to negative 18. Then I'm going to add 8 to both sides, and that's going to give me a negative 10, and then divide both sides by 2, and I get x is negative 5. So now I get the second variable. This is where I now backtrack and plug into one of the originals, because I have two variables that are known, and now I just have to find y. So now let's say I plug into equation 1 to find y. So I'm going to plug in negative 5 for x and negative 2 for z. So I have negative 5 plus y minus 2 is equal to negative 7. So y, when I solve that, I'm going to get y is going to be 0. So there's my third variable. If I write this down as an ordered triple, my final answer would look like this. I want to put my x first, negative 5, then I put my y, then I put my z. This is what it would look like if we wrote it down as an ordered triple. So this is the case where all three planes come together at one point. That would be this case right here with one solution. It's long and it's tedious, but it's not hard. You just got to follow the steps. It just takes a while, and because there's a lot of steps, it's easy to make a mistake, so you've got to take your time. Let's not get this confused with example 2. I'll draw that line. Okay, example 2, I'm going to call this equation 1, 2, and 3. We're going to follow all the same rules again. Okay, so I pick two equations. It doesn't matter which two, any two, and I pick a variable to eliminate. So if I pick equation 1 and 2, you can pick a different 2. It doesn't matter. You'll still get the same answer. I'm going to pick negative x plus 4y plus 2z is equal to 4. And then equation 2 is x plus 4y plus 2z is equal to 6. These are set up so that I can eliminate x right away, so let's eliminate x. So when I add vertically, the x's disappear. For equation 4, I'm going to get 8y plus 4z is equal to 10. Now let's create an equation 5 by picking another 2 equations, but I have to eliminate x again. That's the trick so that this works smoothly. So if I pick, let's say, 2 and 3, in order for my x's in 2 and 3 to be opposite coefficients, I have to multiply equation 2 by 4. So I'm going to have for equation 2, when I multiply that by 4, I'm going to get 4x plus 16y plus 8z is equal to 24. Now I can carry down equation 3. And now I'm going to add vertically so I can come up with my equation 5 with x eliminated again. So that gives me, those disappear, and I'm left with 18y plus 10z is equal to 23. So I have 2 equations now, both with y and z. So I have to eliminate either y or z. Okay, what I'm going to do is I'm going to eliminate the z's in 4 and 5. So I'm going to multiply equation 4 by negative 10. When I do that, that gives me negative 80y minus 40z is equal to negative 100. Then with equation 5, I'm going to multiply by positive 4. That will give me a positive 40z and a negative 40z, so my z's disappear. So when I take 18 times 4, that's going to give me a 72y. Then I get a plus 40z is equal to, and then if I take 23 times 4, that gives me 92. So I have a negative 80, and I'm adding a 72. That's going to give me a negative 8y. The z's disappear, and then I get negative 100 and a positive 92. That gives me a negative 8. So y is going to be 1. So now I need to start back substituting to find my other values. So I'll take y as 1 and plug it into either 4 or 5. It doesn't matter which one. And that way I can find z if I plug it into 4 or 5. So let's say I plug it into 5. So I'm going to take equation 5 and plug in. Do 18 times 1, which is 18, plus 10z is equal to 23. Then I'm going to subtract 18 from both sides. So I'm going to get 10z is equal to 5. So z is going to be 1/2. So here's my second value. Now I'm going to plug back into the original because now I have y and z and I can find x by doing that. So now I'll plug back into, let's try equation 1. I have minus x plus 4 times y. Y is 1, so that's 4. Plus 2 times z, and z is 1/2, so 2 times 1/2 would be 1, is equal to 4. So I have negative x plus 5 is equal to 4. I subtract 5 from both sides. So x is going to be 1. So there is my third answer. So if I write this down as an ordered triple, I have to write my x down first, then my y, then my z. So this would be my final answer if I wrote it down as an ordered triple. Okay, next example. It's not pretty, but it's not hard either. We have to clear the fractions before we even start this problem. If you look, we'll call this equation 1, 2, and 3. If we look at equation 1, we can clear those values by multiplying everything by 12. So I'm going to get a new equation 1 when I multiply through by 12. So I have 12 times 3/4 x would give me a 9x plus 1/4 times 12 would give me a 3y plus 5/6 times 12 would give me a 10z. And when I take 12 times 12, that gives me 144. For the second equation, I'm going to multiply everything by 6 to clear the fractions. When I take 2/3 times 6, that gives me 4x. When I take 1/2 times 6, that gives me 3y. And when I take 1/3 times 6, that gives me a 2z. And when I take 38 over 3 times 6, that's going to give me a 76. Okay, last one to clear the fractions. I'm going to multiply by 6 again. So I have a 1/2 times 6, that's going to give me 3x. Then I get 3y plus 2z, and then 6 times 12 would give me 72. Okay, now I have a system of equations that's easier to solve without all those fractions in it. So we had to do some prep work first to set it up before we started trying to eliminate variables. So if you notice, all of the y's would be easy to eliminate because they're all 3's. So I would just have to switch all the signs to make one a -3 and one a +3. So I'm going to pick equation 1 and equation 2. I'm going to take equation 1 and multiply through by a -1. Then I'm going to carry down equation 2. And then I can add vertically because I have a +3 and a -3. So the y's disappear, and if I add the x's, that's going to give me a -5x. This will give me my equation 4. The -10 and the +2 gives me a -8z. And then I have 144 that's negative, and a +76, that's going to give me a -68. So that's my equation 4. Let's come up with an equation 5 now. And I'm going to take equations 2 and 3 now and eliminate y again. For equation 2, I'm going to multiply through by a -1. So my signs are opposite for the y's. So I get a -4x minus 3y minus 2z is equal to -76. Then I'll carry down equation 3. When I add these, my y's disappear. I'm left with a -x. And look, my z's disappear too, so this makes it a little bit easier on me. I can solve for x right away. So I get -x is equal to, and if I take a -76 and a +72, that gives me a -4. So x is going to be +4. So here's one variable. Now I got to back substitute to find the others. So I'm going to plug x equals 4 into equation 4. I don't want to plug it into one of my originals because I would have 2 unknowns and I wouldn't be able to solve anything yet. I want to back substitute where I only have 1 unknown. So I'm going to take that 4 and I'm going to plug it into equation 4. So I have negative 5 times 4 minus 8z is equal to negative 68. That gives me a negative 20 minus 8z is equal to negative 68. I'm going to add 20 to both sides. That's going to give me a minus 48 when I add 20 to both sides. And then when I divide both sides by negative 8, that's going to give me a 6. So my z is 6. Now that I have 2 variables, then I can backtrack to one of my original equations so that I can find the remaining variable. Now you can plug it into one of these, it's totally fine, but my suggestion is to plug it into the ones where we cleared the fractions because that'll make it a little bit easier. So I'll plug it into equation 1. So I'm going to have 9 times x, which is 9 times 4, plus 3 times y, plus 10 times z is equal to 144. So this is going to give me a 36 plus 3y plus 60 is equal to 144. I'm going to subtract 60 from both sides. And I'm going to subtract 36 from both sides. And that's going to give me 3y is equal to 48. And when I divide both sides by 3, that's going to give me that y is 16. So here are my 3 variables. If I write it as an ordered triple, I write my x first, then my y, then my z.